Let's go ahead today and take a look at lesson 3 of chapter 4, which happens to be adding and subtracting like fractions. I know in elementary school when you guys started working with fractions, one of the things that you guys also had to do was working with adding and subtracting. And so my hope today, after today's lesson and after we go through this, it'll be somewhat of a review for you as we work through it. The objective for the day would be that when you guys leave or after you're finishing watching this video, you're going to have some success being able to add and subtract like fractions, okay? One of the things that I do want to point out when we talk about like fractions, what that means is that means your denominators are always going to be the same already. One of the things that's really important to remember when we are working with fractions is the fact that before we can add or subtract them, we have to have a common denominator. And so the examples we look at in today's lesson are already going to have those common denominators for us, okay? We do have one vocab word that you are going to need to fill in on your vocab web. It is going to be like fractions, so please make sure that you do get that filled in on your vocab web. Okay, what I'm going to do is we're going to go ahead and jump actually to page 284 in your book. As I had said earlier, one of the things that we're going to be doing is being able to both add and subtract like fractions. Something that's very important and that you're going to want to remember is the fact that when you are adding or subtracting like fractions, you're going to add or subtract your numerator. Okay, you're going to add or subtract your numerator. So you may want to underline or highlight the word numerator in there. And then you're going to write your answer over the denominator. We do not add or subtract the denominator, okay? Denominator stays the same. The only thing that's going to be added or subtracted would be the numerator or the number that is on top, okay? So for example, a couple examples you can see here. They have given you 5/10 plus 2/10. Okay, denominator is already the same. Please make sure you look at that right away to check. 5 plus 2, I'm thinking 5 plus 2 and I have 7 or 7/10. And 7/10 is in simplest form. We want to make sure when we are answering these that we do put our answers in simplest form, and you guys can use your divisibility sheet, the half sheet that you had received at the beginning of chapter 4 to help you when you are trying to figure out if things are in simplest form. Okay, take a look at the second one here. We have 11/12 minus 4/12. Again, we've already got a common denominator, so I don't need to change that or mess with that. 11 minus 4 would be the same as 7. Denominator stays the same across, so 7/12, and that would be in simplest form. They did give you examples over here, algebraically speaking, but for your interest, your best interest, it's probably best to look at the number examples that they have given you right now, okay? Fractions that have the same denominators are going to be called your like fractions, okay? Number 1, they're showing with you on a number line, and you guys did some number line work in the inquiry lab prior to this lesson, so hopefully this will be kind of a review. We're thinking 5/9 plus 2/9. Denominators are the same, so I should be thinking 5 plus 2. 5 plus 2 is going to be 7, and I have 7/9. As we take a look at the number line that they have given you, starting at 0, I'm going to go up 5/9 as you can see, and then I'm adding on 2 more 9ths. So add on 2 9ths, where do we end up? We end up at 7/9. Okay, so we can use the number line just to confirm what we came up with for an answer over there. Taking a look at number 2, we have to be careful on this one because this is a negative. Okay, we have a negative 3/5 plus a negative 1/5. So it's going back to your rules for adding your integers. Okay, because they are both negatives, what you're going to do is you're going to add 3 plus 1. Okay, so 3 plus 1, or 3 negatives in a bucket plus another negative in a bucket, would give me 4 negatives altogether. Denominator stays the same, so I have negative 4 over 5. You can see another way that they wrote it is negative on the left here, and then 4/5. And technically you could also write it as negative 4 over negative 5. Okay, those are all going to mean the same thing. So to be honest, it does not matter how you write them. Okay, those 5 all mean the same thing. Okay, as long as you have the one negative with it. As we take a look at got it problems on the bottom, go ahead and pause your video and then complete these problems and then come back to check your answers. Again, the first thing that we're going to do is double check to make sure our denominators are the same, and they are. So 3 is going to stay as my denominator. 1 plus 2 gives me 3. Now I have to ask myself, is 3/3 in simplest form? And it is not. I can divide both of those. 3 divided by 3 would be 1, so my answer should be 1. Okay? can take a look at letter C while I'm over on this side. 5 is my denominator, so 5 is going to be on the bottom. I'm thinking -2 plus -2. They're both negative, so we're going to add those together. 2 plus 2 is 4. And like we said, they're both negative, so we're going to end up with a -4/5 for our answer. Looking at got it problem letter B, denominators are both 7, so I'm going to put 7 as my denominator. -3 plus 1. I've got a negative and a positive, so technically I'm going to subtract those two. So 3 minus 1 would be 2, and 3 has a larger absolute value, so -2/7 would be our answer there. Taking a look at letter D, 4 is our denominator, so I'm going to put 4 on the bottom. I've got -1 plus 1. Both signs are different, so we actually subtract those, so 1 minus 1 would be 0. We don't need to put a negative because we're not going to have a -0. 0 divided by 4 is going to be the same as 0, so you would just write that as 0. Sometimes they will cancel out and just become a whole number, like they were on example A and example D. As we take a look at page 285, okay, on the top they've given you an example. Sophia ate 3/5 of a cheese pizza. Jack ate 1/5 of a cheese pizza and 2/5 of a pepperoni pizza. How much pizza did Sophia and Jack eat all together? Keyword is all together, meaning we're going to add. So we're thinking 3/5 plus 1/5 plus 1/5. Okay, denominators are all the same, so my denominator is going to stay as a 5. I can think 3 plus 1 plus 2. Well, 3 plus 1 is 4. 4 plus 2 would be 6. Okay, so when I think about 6/5, that would also reduce down because it's an improper fraction right now. 5 will go into 6 one time. 6 minus 5 is 1, so I have 1 and 1/5 as what you can see your book has there as well. Taking a look at got it problem letter E, Eduardo used fabric to make 3 costumes. He used 1/4 of a yard for the first one, 2/4 for the second, and 3/4 for the third. How much fabric did Eduardo use all together? So we're looking at adding. I've got 1/4 plus 2/4 plus 3/4. So looking at my denominators, they're all 4, so we're going to put 4 on the bottom. Looking at my numerators and adding them, 3 plus 2 would be 5, 5 plus 1 is 6. Now 6/4, we don't want to leave it as that because it's an improper. So I know that 4 will go into 6 once. 6 minus 4 is 2, so it'd be 1 and 2/4 or 1 and 1/2 when it reduces down. Next examples are looking at subtraction. So we're looking at -5 minus 3/8. Again, go back to your rules for when we were working with integers. We're thinking -5/8 plus, subtraction changes to adding. We want to add the opposite. The opposite of 3/8 would be a -3/8. Okay, so now both of these are negative, so I can go ahead and add 5 and 8, or 5 and 3 to get 8. So I end up with -8/8, which would be the same as -1, and you can see they have that there. Please remember to change those subtraction problems, especially when you're dealing with negatives. Subtraction problems change to addition, and we always add the opposite. Okay. Same thing on number 5. 5/8 minus 7/8, denominator is the same, so we're thinking 5 minus 7, or we could think 5/8 plus -7/8. 5 plus -7 would give us a -2/8, or when it reduces down, it'd be a -1/4. Okay. Go ahead and pause the video right now and work on got it problems F, G, and H. As I take a look at got it problem F, I'm taking 5/9 minus 2/9, so my denominator is going to be 9. 5 minus 2 is a number, or are integers that we can easily subtract, so I do not need to write that as an addition problem. You can if you want to. If you wanted to write it as 5/9 plus -2/9, -2/9, you're more than welcome to. 5 minus 2 would give me 3/9. Now 3/9 will reduce down to 1/3. Again, please remember that we are putting them in simplest form and reducing them to their lowest terms. Negative 5/9 minus 2/9. Because I'm dealing with negatives and subtracting, I'm going to go ahead and rewrite that as an addition problem. First fraction stays the same, subtraction changes to addition. Opposite of 2/9 is negative 2/9. So negative 5 plus negative 2 would give me 7 negatives, or negative 7, and then 9 is my denominator. Okay? And then taking a look at letter H, hopefully when you worked on this one, you were thinking negative 11/12. Subtraction changes to addition. Opposite of negative 5/12 would be a positive 5/12. So I've got a negative plus a positive. I'm going to end up subtracting those. 11 minus 5 would give me 6. 11 has a larger absolute value, so my answer is negative. And then 12 is my denominator. Those both can be divided by 6. So I'm going to divide them both by 6. Negative 6 divided by 6 would be a negative 1. Over 12 divided by 6 would be 2. So our answer should be negative 1/2 as you worked through that one. Next page is choosing an operation. So you're going to be looking at what are you actually going to do. Are you going to add, or are you going to subtract? On your assignment, occasionally they will ask you to choose an operation, so you are going to have to identify whether you are going to add or subtract. Okay. Looking at number 6, it says about 6/100ths of the population of the United States lives in Florida. Another 4/100th lives in Ohio. About what fraction more, indicating a comparison of the United States population lives in Florida than Ohio. So because we're looking at more, looking at the difference between the two, we're actually going to subtract them. So you can see the fraction 6/100ths minus 4/100ths. 6 minus 4 would give us 2/100. Divide those both by 2, so we have 1/50. And then answering it, about 1/50th more of the U.S. is going to live in Florida than in Ohio. Let's go ahead and take a look right now. I would like you to complete your guided practice problems on page 286. You can go ahead and do numbers 1 through 7. Looking at your answers for your guided practice problems on page 286, you can see number 1, denominator is already 5, 3 plus 1 is 4, so we're going to come up with 4/5, and that's simplified. Looking at example number 2, 7 is my denominator, 2 plus 1 is 3, so we end up with 3/7. Looking at example 3, you've got 3 fractions to add together, 8 is your denominator, 5 plus 1 is 6, 6 plus 3 would be 9, 9/8 is going to reduce down to 1 1/8. Looking at number 4, we're subtracting. Negative 4/5 minus negative 1/5, so technically we're thinking negative 4/5 plus a positive 1/5, which is going to leave us with negative 3/5. Here we have 5/14 minus a negative 1/14, so again we're thinking 5/14 plus 1/14, which would be 6/14 or 3/7. And then number 6, we're thinking 2/7 minus 6/7, or 2 minus 6. Same as 2 plus negative 6, which is going to give us negative 4/7. That's kind of hard to see there, but that should be a negative 4/7. And then looking at number 7, deciding what you are going to do. Of the 50 states in the United States, 14 have an Atlantic coastline and 5 have a Pacific coastline. What fraction of the U.S. have either an Atlantic or Pacific coastline? So we're looking at both of these together. So 14 out of 50 plus 5 out of 50, 14 plus 5 would give us 19/50 for an answer. At this time, you can go ahead and start working on your practice problems. The directions or the page numbers are also on the website, but you're going to be working on page 289.